In this session, let's focus on a problem from perturbation theory which was asked in JEST exam 2023. So here we are given a non-Hamiltonian H0 and a perturbation H prime, and we need to find the first order correction and the second order correction. Even without going through the complete steps, without using pen, we can solve this problem. Because the H prime we are given, it does not contain diagonal elements. Diagonal elements are 0. Therefore, the first order correction will be 0. And the second order correction to ground state is always negative. Second order correction to the ground state is always negative, which means option C is the correct answer. First order correction is 0 and second order correction will be negative. But for the complete understanding of the problem, let's go through complete steps. Let's go through full steps. So H0 we are given is, if we multiply alpha and omega inside and add, H0 will be equal to alpha plus omega 0 0 alpha minus omega. This is the diagonal matrix, and we know that for a diagonal matrix the diagonal elements are the eigenvalues. So the known energies, the free Hamiltonian is H0, the non-Hamiltonian is H0, and the known energies are E0 is equal to diagonal elements which are alpha plus omega and alpha minus omega. And the smallest one here is alpha minus omega, the least one here is alpha minus omega, which will be the ground state. So the ground state energy is alpha minus omega. We also know that the eigenstates corresponding to alpha plus omega will be 1 0, and eigenstate corresponding to alpha minus omega will be 0 1. Let's denote 1 0 state by ket G1 and 0 1 state by ket G2. So ket G2 is the ground state. Now let's calculate the first order correction. So first order correction to the ground state, it is defined as E10. The 1 on the top indicates that it is first order correction, and the 0 in the bottom, it means this is with respect to ground state. So E10, this is equal to G2, which is ground state, H prime G2. So this is equal to 0 1 0 epsilon gamma 0 0 1 0 1 as it is. If you multiply these two, you will get epsilon gamma and 0. So this is equal to 0. So the first order correction to the ground state energy, this is 0. Now let's calculate second order correction to ground state. So second order correction to the ground state, it is defined as, let's write the general definition first. So if you want to calculate the second order correction with respect to nth state, then it is defined as summation m not equal to n m h prime n modulus square divided by En0 minus Em0. So in this case, we have to find E2 with respect to G2 Since there are only two states, G1 and G2, and G1 cannot be equal to G2, this implies there is no need of summation. G1 H prime G2 modulus square divided by EG2 0 EG1 0. There is only one such state which is not equal to G2, so therefore there is no need of summation. So this is equal to 1 0 0 epsilon gamma 0 0 1 modulus square, the whole divided by EG2 0 is alpha minus omega and EG1 0 is alpha plus omega. So this is equal to 1 0 epsilon gamma 0 modulus square by minus 2 omega. This is equal to minus of epsilon square gamma square by 2 omega.